Well, hello, everyone. Thank you for attending today's webinar, Unlocking New Insights into Cities with 2D Aerial Data and 3D Digital Twins. My name is Amy, and I am the Membership Associate here at National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to learn more on how to get involved, please visit us at www.nishik.org. Some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A. And during our presentation, our chat will be monitored for questions and comments. If you'd like to add any questions or comments, please place your questions right in the chat box to be read aloud at the end of the presentation. Additionally, a recorded version of the webinar will be made available afterwards, so be on the lookout for an email with that information. And with that, I'd like to introduce today's presenter, Travis Gelati from Hexagon. I will now turn it over. Thank you again for joining us. Travis?
Hello, everyone. Happy GIS Day to everybody out in virtual land. Let's get started with today's webinar. As Amy said, my name is Travis Gelati. I have nearly 25 years of experience in the geospatial market, predominantly focusing on aerial imagery and photogrammetry. I'm speaking to you now as the Director of Technical Content Solutions and the Product Manager for the Hexagon Content Program. I have a lot to cover today, so let's get started, shall we? Over the course of today's webinar, I will discuss how we assist states in the acquisition and access of our remarkable image data products through our Content and Content Plus programs. But perhaps what I'm most excited about is to introduce all of you to our Metro HD program and full stack digital twins for city areas. This is a revolutionary offering in the aerial market, and I can't wait to share it with all of you. This data will soon be accessible as a standard content offering and available through our Content Plus initiative as well. Finally, for our technical folks, I will discuss a bit about our hybrid data initiative and how that strengthens our data sets and ultimately benefits our customers such as yourselves. I'd be remiss if I didn't speak to those of you who may not know who we are at Hexagon. Hexagon is a global company that is not like any other company you know. Our portfolio of sensor, software, and autonomous solutions is completely unique. The common aligned focus is the collection, processing, analysis, and visualization of data to empower an autonomous future. This can mean connectivity, as well as automated and/or augmented reality applications powered by the digital twin over our full suite of product offerings. This is what we strive to give back to the industry. Let me explain. So how did Hexagon, get here? Well, I can confidently say that the road to autonomy is enabled by our unique set of core capabilities. As I stated earlier, our legacy has always been linked to data. We emerged as a leader in sensor solutions nearly 20 years ago, and that has enabled our digital capture and positioning of the physical world. We added software solutions to unlock the value of our sensor data to now offer the ability to design, simulate, and provide location intelligence of real-world scenarios. In 2020, 70% of our development employees have a software background, while only 30% are mechanical or electrical engineers. As such, we are well positioned to combine things like machine learning and artificial intelligence into our sensor and software designs to create powerful autonomous solutions through the entire acquisition and processing chain. What this means is that as we forge ahead, we'll be putting together all of the pieces and parts to derive the digital twin initiative from every level, leveraging insights from terrestrial and indoor to mobile applications at the street level, and finally, the aerial perspective as we are discussing today. We are continuously looking for ways to capture better data and transform that data into actionable information. All of this is what we refer to as our smart digital reality. Our core capabilities in sensor, software, and autonomous technologies give us a unique point of leverage, the convergence of the physical and digital worlds. It's far more valuable than a continuous flow of information, feedback loop, or digital twin. Take any project that you are currently involved with that leverages geospatial data, perhaps a construction site or landscape city planning initiative. Imagine having seamless access to the physical world information, any information about what's happened or happening over that area of interest, accessible to you from anywhere, as well as autonomous decision-making capabilities like inventory delivery adjustments, change detection based on work progress or other aspects of our changing and dynamic daily lives. The smart digital reality is a digital replica of a complete physical world where all associated things, places, and processes within it are machine readable and subject to the power of algorithms. It's what we aim to deliver with every solution we provide. Let's turn our attention to the Hexagon content program data and offerings. For those of you that may be unfamiliar, let me outline what the Hexagon content program currently provides. Simply stated, machine readable data with superior consistency and positional accuracy under flexible licensing terms. Our mature workflows produce the highest level of photogrammetric and radiometric quality, where our efficiently planned acquisitions over the course of a single season mean highly consistent data that is ideal for base mapping and visualization, as well as the most advanced machine learning and AI applications. It is important to note that we as Leica Hexagon control the entire workflow from building and integrating the sensors in our aircraft, planning data collection missions based on the most stringent acquisition specifications, and finally processing the data with software designed to maximize the richness of the data sets. Our off-the-shelf products include 4-band multispectral data at 1 foot statewide and 6-inch urban GSD. We're hopeful that during the next refresh cycle, most of the 1 foot statewide coverages that we currently offer will transition to a 6-inch coverages such as we see for the state of Texas most recently. As always, all of our image data can be purchased directly through our online store or streamed directly into a variety of GIS software and custom applications via WMS and WMTS protocols. In addition to our imagery products, we also offer imagery-derived elevation data, which have been growing in popularity by leaps and bounds recently. Our off-the-shelf elevation data includes digital surface models at 1 foot and 6-inch resolutions that can be delivered in point cloud and or raster formats, and a 5-meter hybrid and automatically filtered DEM dataset. If you're unfamiliar, the Hexagon content program provides 100% complete coverage of the US. Just over 3 million square miles of that coverage is at a 1 foot resolution, and 200,000 square miles is available at a 15 centimeter or 6-inch resolution. We plan to add another 1 million square miles to these totals in 2021 through refresh of 16 states, as you see on the graphic to the right. 4 of which, Washington, Utah, North Dakota, and Delaware, will join Texas as being full 6-inch statewide coverages. As part of the innovation ecosystem, we are continuously listening to the market, customers, and potential customers to respond to shifting user requirements that are becoming more demanding, including the need for higher resolution, additional data products, and improved acquisition tempos. This included a shift of our data storage and distribution to the AWS platform in 2019 to make our cloud solutions faster, reliable, and more widely available. Further, and as many of you are probably aware, we have made recent sensor technology advancements as well, when the market challenged our R&D team to provide acquisition efficiency and provide more options on resolution. This led to our Content Mapper platform, a wide area mapping large format sensor designed specifically for the content program that collects data more quickly and efficiently without sacrifice to accuracy or data quality. As we see in the graphics in the lower right corner, as compared to our traditional ADS platform, the innovative design allows for double the coverage at current resolution or 1/2 the resolution at current flying heights. The ability to provide higher resolutions over wider areas can lead to increased flight efficiency during the leaf off season, which are traditionally much smaller acquisition windows, or overall increased refresh rates. Customers are able to benefit from these innovations by, well, just being customers. Let's take a bit of a more focused look at the content and Content Plus initiative within the program. Within our baseline state content program, you get high quality data without the price tag. Collecting over 1 million square miles of data annually, our efficient acquisition methods and volume-based methodologies for processing, archive, and accessibility provides a cost savings when compared to one-off spec collects that is passed directly to you. You also get scaled data collection and access. Our tailored data specification and pricing conditions enable you to support large, diverse user groups. Flexible use terms, delivery vehicles, and user administration tools allow you to extend services and pricing across the state. State organizations can work together to share the load, whether it be through a centralized access system or funding pool to to pay for the data acquisition. And further delivery on demand. Multiple data delivery and consumption models ensure smooth integration with existing workflows via OGC compliant WMS and WMST cloud streaming. When you sign up for the content program, current data for your state is immediately available through the program via streaming and a one-time hard pixel delivery. As new imagery is added during the term of your agreement, you get access to this data via your streaming service. Content Plus is an initiative that allows states to access and use our data in a way that is slightly more customized to their needs. While options are not completely customizable, Content Plus does allow us to unlock and have conversations to work towards more specific data collection options beyond what is currently offered through content. This could include higher resolution collects or increased refresh rates better than the 3-year current option. It's important to note that this is a licensed data product. So what does that mean exactly? Well, if you're looking to fund your own collect, for example, it means we take away the headaches associated with managing an RFP for airborne acquisition, as they're no longer needed, acquiring, processing, and QCing the data, as well as managing the data storage and delivery, all of which come at a cost to your organization, which further includes IT personnel, and infrastructure, and the know-how to optimize usage and troubleshoot any issues that may arise. However, we do place some restrictions on the data usage, for example. While the data can be shared within the state to registered constituents, the data cannot be posted for public consumption as a general rule. We do allow some statewide data to be posted at 2x the resolution, but this is generally handled in a case-by-case basis. In addition to delivery to the state and their constituents, the data becomes part of the Hexagon content program, which is accessible to other organizations with a subscription. While this may seem restrictive, it allows data access by states to come at a much cheaper price overall in the end. Our easy to access data library allows you to focus on your user base and their applications, which is the most important piece of the puzzle. While the Content Plus program may not ultimately lead to a full custom data acquisition, we often find that our customers get just as good, if not better, data accuracies and resolutions than what they were previously losing with far less effort. This is important stuff, so let's summarize how this is put into practice. The baseline content program subscription allows direct and immediate access to the latest vintage of your state's data, either via a streaming connection or a one-time delivery of the hard pixel data at sign-up. We also allow the identification and enrollment of organizations within the state or directly affiliated with the state to be included for access. States currently involved find this is a great way to ease the financial burden through the pooling of funding to support the baseline program or purchase options as part of Content Plus. Finally, we offer flexible licensing terms over 1 or 3 years in duration. The benefits to state with the 3-year term is the ability to spread the cost over multiple years, while perhaps benefiting from the 3-year refresh cycle of the program to gain access to any updated imagery acquired during that window via your streaming access. The Content Plus initiative includes all of what the baseline subscription has to offer, while also including potential access to a variety of options, which could include higher resolution focus areas. We have currently seen Texas and California take advantage of this through the purchase of their metropolitan areas at a higher resolution than their statewide coverages. The AOIs for these higher focused areas do not need to be metropolitan areas either, but can be at a variety of differing geographic extents, including counties or even council of government regions. We also offer a variety of collection options. This could include leaf-off acquisitions, again, higher resolution refreshes outside of metro areas, or even higher refresh cycles. Finally, we have a variety of value-added offerings, including access to our DSM data, and perhaps most importantly of what is seen on the right, our Metro HD offering, which provides 9 high-resolution data sets focused on metro areas. We're going to get into this in the following slide, but the Metro HD offerings include high-resolution imagery, LiDAR, elevation, oblique imagery, land use, and other 3D products. In the end, Content Plus is really all about finding out how Hexagon and your state organization can work best together. If you're still not sure about the Content or Content Plus programs, talk to one of our current program partners listed here. This slide graphically illustrates the states currently involved in the general state and state Content Plus programs. While the spirit of the agreement remains the same for each state, that is to say the delivery of archived and updated imagery, each state's needs is a bit different and the content program allows for that. So now that the cat's out of the bag for the Metro HD program, let's take a closer look at the Metro HD program in detail, including the standard products that will soon be available as part of the Hexagon content program. In addition, I'll also take this opportunity to outline our hybrid data initiative and how we feel our approach leads to improvements over what is currently available on the market. The workhorse in the Metro HD program is our CityMapper-2 sensor that is a follow-on to the CityMapper-1 sensor developed in 2016. So while this may seem like a new concept, this is certainly not a new technology for us at Hexagon. It is important to note that the CityMapper-2 system is composed of subsystems that are world-class on their own right. This is not a piggyback sensor where one imaging stream is dominant and the other accompanying systems are introduced to provide context only. Our true hybrid acquisition relies upon our 150 megapixel passive imaging system and the 2 megahertz Hyperion 2 Plus LiDAR system that is found, as some of you may know, in our Terrain Mapper 2 sensor. So if we look at the CityMapper sensor on the left, we first see the LiDAR Hyperion 2 Plus sensor in the middle, which offers direct measurement of distance to the ground. Complementary to that are two nadir posed cameras, one collecting RGB information and the other collecting near infrared information. Added to that are 4 45-degree view angle oblique sensors. As with everything we do, there's no compromises here either on these oblique systems. They are the same 150 megapixel sensors as the nadir views are. The Metro HD program will be introduced as its own initiative, such that we're flexible to respond to customer needs and work for hire contracts that will add depth to our content program, while also being added as an option within our Content Plus program. For example, instead of buying up Metros at 15 centimeter product level, you'll now be able to select the Metro HD purchase option. As with all data collections, as we fly specific areas, the data will be added to our data store for broader access. We are currently flying and processing data in the following major cities: Munich, New York, Tokyo, Dallas, Cologne, Vienna, Milan, Amsterdam, Stockholm, Stuttgart, Frankfurt, and potentially more coming in 2022. The data products include LiDAR point clouds, mesh models, 3D buildings, land use maps, DSMs, DEMs, obliques, true orthophotos, and standard orthophotos. With that being said, let's take a deeper look into the actual data products. Our LiDAR data offering represents the raw elevation point cloud after system calibration, noise removal, and strip adjustment. The data is encoded with RGB and CIR spectral information from the corresponding aerial imagery, in addition to the standard LiDAR intensity. This creates a product that goes beyond pure elevation, thus providing a more realistic representation of the image seen. This data can be further classified via automated or manual routines to produce surface and elevation models, as well as perhaps gain a deeper understanding of the surface objects within the scene using the added spectral information to classify based on material type. The off-the-shelf product offering will target a density of 20 points per square meter and be delivered in an LAS version 1.4 format in 1 kilometer tiles. We will offer a standard resolution ortho-rectified image data product as well. I use the term standard in that this product includes the visual effects of building lean that are represented in the majority of ortho imagery products currently on the market. This product is delivered at a GSD of 2 inches with 4 spectral bands, that being blue, green, red, and near IR, in GeoTIFF format in a standard 1 kilometer tiled structure. In addition to our standard orthorectified imagery, we will also offer a true orthorectified product. This product is rectified using the LiDAR DSM as opposed to a DEM, and in the process removes the appearance of building lean in the imagery. Each pixel is represented as if viewed from directly above in its true orthographic position. This produces a bona fide 2D map with high resolution imagery context. The removal of occlusions means that all surfaces are now visible, which makes this product excellent for feature extraction of building footprints, street furniture / infrastructure, or as an ideal tool in urban planning. Similar to the standard ortho product, this imagery is produced with a 2-inch GSD, 4 spectral bands in GeoTIFF format, and a standard 1 kilometer tiled structure. It's important to note that all of our orthorectified images are processed to maximize resolution, clarity, and the removal of differential scaling inherent in aerial imaging scene reconstruction. Seam lines are adjusted manually to optimize image scene content, and all imagery is subjected to a rigorous QA/QC routine prior to release. Up next is our DSM dataset. This layer is produced from the first return LiDAR data that represents all primary reflective surfaces of built-up areas, such as buildings, transportation, and other general infrastructure, as well as natural environments included vegetating coverings and trees. This makes an excellent product for use in line of sight studies, be it for solar or RF planning, as well as volume estimation and other asset inspections. The resolution of this data set is 2 inches. It is important to reiterate before we move on that this is a departure from our traditional DSM program content program product that is derived from image-based photogrammetry. The DSM for the Metro HD program is derived from LiDAR data. We will now move on to our artificial intelligence layers derived from the exploitation of either the input LiDAR data or image data, or both together. What we see here is a raster land cover map where each pixel is automatically assigned to one of a possible 20 classes, such as pervious areas of grass and trees, and impervious ground cover, such as concrete and asphalt, vehicles, rail tracks, and buildings, just to name a few. This is a single band indexed raster image with a 2-inch resolution and delivered in GeoTIFF format. In the urban environment, this data layer is a key input for RF engineering or planning, ecological modeling and analysis, or even distributed heat mapping within the urban environment. The next slide takes us to a combination of a few data product layers in the Metro HD program. The base map is the land cover layer explained in the last slide. However, displayed on the top of the base layer are 2 3D data sets that include models of trees and buildings. The tree data layer contains tree objects with a tree crown modeled as a modified sphere. Attribute information delivered in CSV format includes tree positions, height, crown, diameter, and crown volume. Buildings are delivered at the LOD2 level, which includes footprints, roof structure, which includes pitch angle and orientation, and the height of the reconstructed models. This is a city GML compliant data set that is delivered in a format that facilitates efficient storage, exchange, visualization, and analysis. As stated earlier in the presentation, the CityMapper-2 incorporates 4 oblique cameras oriented at 45 degrees from nadir and positioned at intervals of 90 degrees with respect to the direction of flight. These oblique images that are collected are available as a data set on their own. All of this imagery data is accompanied by a text file that includes corresponding exterior orientation parameters based on a refined GNSS solution and bundle adjustment. Spectral bands are red, green, and blue. And finally, all images are radiometrically balanced to minimize the effects of different oblique viewing angles, but are not distortion free. GSD on an average here is 2 inches in this data product. Finally, we get to the culmination of all these image data products, and that is the aerial mesh. This product is derived from a combination of imagery and LiDAR to create a virtual representation of the real world. For those unfamiliar, this product is a mesh of triangles, which represents the surface of all natural and built-up objects within the image scene. Aerial mesh texture is achieved by assigning 2D RGB image data for each corresponding triangle that forms the mesh. The foundation of the aerial mesh is a spatial data structure that enables hierarchical level of detail, so only visible tiles are streamed and rendered, improving overall performance and visual quality at any scale. The visualization product is applicable to observe and monitor change, perform landscape planning and analysis, city planning and smart city integration, line of sight analysis, and transportation analysis as well. So what are the benefits of the hybrid approach? As I alluded to previously, the CityMapper-2 sensor is not a LiDAR or imager with other sensors on board simply to provide context. These two are well-defined and popular products from the Leica family that have been combined to offer superior performance for a variety of applications. This strengthens the resultant data products as we are able to leverage the strength of each system either individually or in combination. The Hyperion 2 Plus LiDAR is a highly efficient, full waveform, 2 megahertz linear mode system that allows up to 15 returns per outbound laser pulse. Our gateless multiple pulse in air technology allows for the handling of 35 points in the air at any one time, which allows us to take advantage of the 2 megahertz pulse rate while handling the complex terrain in urban environments where we often see diverse changes in the heights of surface features. The MFC 150 sensor is a 150 megapixel high resolution imager with approximately 14,000 pixels in the cross-track direction and the ability to collect RGB and near infrared spectral data. However, perhaps the most applicable advancement to discuss as it relates to product quality is the mechanical forward motion compensation. This offers superb low light performance and thus flexible flight operations. This is one system that provides everything you need. That is to say, multiple modalities, co-registered and bore-sighted instruments, one GNSS stream, and further temporal consistency. Since the data is collected concurrently, there are smaller changes in the scene that need to be dealt with in post-processing, or that can lead to inconsistencies in the reconstructed data product from 2 or more collects. This slide illuminates the effects of the forward motion compensation. This image was captured at a less than optimal time of the year with a very low sun angle of 27 degrees, as can be observed in the long object shadows. The image was acquired at 100 knots in 1/200th of a second, which is usually far too long of an exposure time for an aerial acquisition, especially at the aircraft speed that we were flying. We see the non-FMC corrected data on the left and the FMC corrected data on the right, and we see huge improvements in resolution and image quality. To reduce the motion blur without FMC, we would have to dramatically reduce the exposure time, which can lead to noise in the imagery. In our case, the FMC allows us to avoid this compromise and obtain the best image quality possible and a nice sharp image as we see on the right. Not only does this allow us a wider range of acquisition times and duration, it also helps us combat the low light conditions often found when imaging in an urban environment. Beyond imaging, the Hyperion LiDAR employs a circular scan pattern that aids city modeling by providing a forward and backward look angle and not simply sideways. This increases the volume of data capture on vertical surfaces, allows a more even point distribution, and thus improved modeling on the facades of objects. In terms of flight operations, this removes the need to fly additional perpendicular lines to fill in the gaps, which means lower acquisition costs. If we take a look at the image on the right and the points associated with the profile slice in the above portion of that image, we observe more than adequate representation of building sides, providing a more complete representation of the scene in far less time. The combination of these two technologies creates a well-matched subsystem performance with no compromises. In the left image, mainly attributed to our FMC integration, we see high resolution with unparalleled sharpness and crispness. We see vibrant colors and, more importantly, details and shadows. In the image on the right, we see tremendous accuracy, exceptional smoothness, and sensitivity in the smooth surfaces of the LiDAR data. And we can even see wire detection. However, to have the best hybrid system, it is not enough to just combine the best LiDAR with the best image system to aid digital twin creation and support city modeling. The key is to combine the subsystems in a way that optimize image quality and LiDAR accuracy and sensitivity. Remember, we fly only once, and we need to get the specifications fulfilled with just one flying height and at one flying speed. So let's go a bit further as to why we believe the hybrid approach is the best approach. Currently in the market are organizations using imagery only as a foundation for city modeling. However, we have seen that the introduction of LiDAR increases the accuracy of the data and the robustness of the reconstruction of the data products. Simply stated, having LiDAR and imagery provides us the opportunity to use the best and most comprehensive measurements available. This includes imagery having a high accuracy in the X and Y plane, whereas LiDAR has its higher accuracy in the Z component, which is certainly complementary. Imagery generally creates strong top surface models, as the ability to measure and model details is based largely on image resolution, which can often be denser than LiDAR. However, since imagery is a passive system and reflectance based, there exist limitations operating in shadow or generally low lit areas that are not affected by an active LiDAR system. Shadows make it quite difficult to get enough points to accurately reconstruct an area in photogrammetry, and thus the result modeling suffers. LiDAR as an active sensor allows you to make measurements and produce data even in shadow areas or during complete darkness. And further, LiDAR has the ability to penetrate the small gaps in vegetation, and with its multiple returns allows us to observe the ground in vegetated areas, which is impossible using imagery only. Finally, having image data as a complement to LiDAR is much better for interpretation, context material surface ID, classification of the data, and overall usability. In addition, because this is a 4-band data product, which includes the near infrared channel, we can extend data analysis and processing to the calculation of vegetation industries. This can be extremely helpful as we see a number of cities attempting to characterize their vegetation for general landscape and urban planning. In addition to being able to leverage the right technology for the application, we went a step further in making certain the sensors are optimized to work together. For a hybrid system, we have matched the field of view of the subsystems, as well as matching the GSD with the LiDAR point density. Investigations have shown that a nominal LiDAR point spacing has an optimized accompanying GSD as well. We have balanced the integration of these two systems without compromises to either of the components. This slide shows the final results over one exposure event. On the left is the nadir and oblique images, while on the right, we observe the images projected to the ground and aligned with the LiDAR swath width as well. Let's finish up today's discussion by looking at some of the inconsistencies in model data that can be alleviated completely or minimized through hybrid data acquisition and processing. Point clouds generated from imaging only, even if flown with very dense overlaps to facilitate dense matching, still show problem areas where point extraction is not good enough. This is due to an inability to confidently match pixels in 2 or more images, which is a requirement of stereophotogrammetry to reconstruct elevation. Areas of concern include occlusions in canyons. Image reconstruction will struggle in canyons due to low light levels in imaging geometry. We also have areas of concern in homogeneous or non-textured surfaces. We find that these areas are on untextured roads, concrete, and sometimes in water areas. Once again, it's difficult to confidently match pixels for stereo reconstruction, and we see this confusion manifesting itself as noise. LiDAR only needs one single point to generate elevation, not a match. So we see much better returns in elevation in those areas with LiDAR. Further, vegetation imagery has no penetration and will only be able to reconstruct the top of the canopy. In an image-only environment, this can be further exacerbated by attempting to find matches in a very complex scene structure with the leaves, especially if there is a slight breeze on the surface during acquisition. And finally, as we have alluded to many times, image reconstruction does struggle in shadowed areas. Some people in the market say that everything can be done with just imagery, and we at Hexagon know this not to be true, as traditionally an imagery-only approach struggles with finding points in the areas just discussed in the last slide. What we see here is a terrific example of what LiDAR can bring to urban mapping. On the left, we see an image-only derived model. On the right, we have an imagery and LiDAR derived model where we can pinpoint details not otherwise visible in the image-only approach. First, we observe the assistance of oblique scan pattern and the robust point densities on vertical surfaces. On the left, we see a rough surface, while on the right, we see an improvement in smoothness with LiDAR. Second, in narrow and occluded areas, LiDAR provides increased model stability. In areas where it is quite narrow, you won't get enough points on the ground to match the small pathways between the buildings in the imagery. While adding LiDAR on the right, you see a nice smooth representation and a nice transition between the surface and the interface. And third, we observe the assistance from the LiDAR approach in shadow areas. Looking in the backyard, you will see that it is quite noisy. However, if you look in the image on the right side, as we introduced LiDAR, we see better shapes and outlines in all of the buildings, especially in the lower right corner. So here's a further example involving buildings, shadows, and roads. In the imagery only representation on the left, we see that in the shadow, the road is quite bumpy, and the transition between building and roads is often quite noisy and not smooth. We also see a little bit of the creep of the road or sidewalk in this case, creeping up the side of the building. When we add LiDAR data to the mix on the right, we see a much smoother representation of the road, the interface between the sidewalk and the building, as well as just a general representation in the shadow areas. Also for vegetation, clarity under trees. In the left-hand side, imagery only, you see quite the blurry blob underneath the trees. In the image on the right, you see a much better defined tree canopy, and you also see a tree stem in the center of the image. Finally, without belaboring the point, we look at a high-rise city center in the US. Advantages in this area include full acquisition to the ground in a highly shadowed environment, separation of buildings with the ability to better sense the data in the shadows and the close buildings with LiDAR. And here again, in deeper shadow environments, we see an improvement with LiDAR. So finally, I can leave you with a little bit of eye candy as we wrap up this presentation. I will try to play the video. This may skip a little bit, but I think it's too good to pass up. So while I am talking on, you can see this is an aerial mesh of New York City and Central Park that we recently collected over the summer and have put together as part of the Metro HD program. So just to reiterate a couple important points, the Hexagon content program provides stable and robust data that is easily accessible for the entire continental US. Content Plus extends the program to allow for buy-ups of increased resolution, refresh and acquisition types, as well as access to the Metro HD datasets. And finally, hybrid acquisition and processing of 2 world-class subsystems is a unique offering from Hexagon that provides tremendous benefit for city modeling. With that, I will conclude today's presentation. Thank you for your time and attention.
Thank you, Travis, for that wonderful presentation. Now we'll take some Q&A. If you have a question, feel free to pop it into the chat and I'll be read aloud right now. One question we have is, if the Hexagon content program is an off-the-shelf licensed data program, how are you able to deliver on tailored specs at a state or city level?
Well, simply stated, we own the pieces and parts that are involved in the entire process. We own the aircraft used in acquisition. We process the data and distribute that based upon our own workflows and IT infrastructure. As a result, we can make any decision that we feel is beneficial for ourselves and our customers.
And what are the requirements for streaming users who may also need negative copies of the imagery?
So as part of the content program sign up, there is a one-time delivery of the current vintage in our library via removable hard drive. For members of Content Plus, we can look into other delivery options such as AWS S3 to S3 transfers of our cloud optimized GeoTIFF imagery, or other mechanisms that a state may want. Can't say we can do everything, but with enough negotiation and discussion, we can probably get to where everybody is comfortable.
Another question that was asked, how can we access or preview data samples from the content program in Metro HD to make sure it's right for us?
You can simply log onto our website and download some samples directly. Or if that won't work, you can contact myself, or if you know other sales professionals at Hexagon, you can contact them and we can work to get the samples in a different way that meets your needs. While on our website, you can also sign up rather easily, I might add, for a trial subscription to our streaming service to see if that is right for you.
And one other question, how can state governments manage data distribution through a streaming license, especially around controlling levels of public domain?
Data distribution in the program is controlled via login and password. Each user in the system has their own unique access credentials. And each state can provide at least one person to act as system administrator that has the right to add and delete users as needed. So password and specific login protected, and then we leave it up to the states to administer that access for themselves.
If anyone else would like to ask a question, please submit your question now in the chat box. Well, I think that was all the questions asked. Well, Travis, thank you so much again for this wonderful presentation. Once a reminder to the audience, this is a recorded presentation and will be sent out to you after following the presentation. Once again, thank you, Travis, and I'd like to thank all the audience for attending today's webinar. Looks like I can give you some time back.
Thanks, everybody.
Have a good day, everyone. Bye-bye.